almost forgot to do this. So I've just started back the recording, and welcome to our CIS117 Hangout for week 6. And we're going to be exploring some parallel exercises for the week 6 assignment. And I will publish these in the course shell. They differ a little bit from what's in the textbook. Our first query is actually going to be creating a view. And a view is like a materialized query that has some permanence so that we can refer and build other queries against it as if it was a table. Okay, and so what we're going to do to begin with is using the TAL database, we're going to create a view named recent orders, and it consists of all records from the orders table for orders placed in the last year from the current date. And by making sure we use a little date arithmetic rather than using a hard-coded date. I could say, well, today is September 26, 2016, so I'll just use the date September 26, 2015. The problem is with every passing day, that gets increasingly inaccurate, and at some point we would have to recode it. So it's better that we build it using date arithmetic. We don't have a date subtract function, but we do have a date add function, and we can add in a negative number in 1-year increments and use today's date, and that's where the magic happens. Gets that from the system date, and on your computer or on actually on the server computer, whether that's your computer or a computer up in the cloud, and so that is going to be perpetually correct. Okay, so again, we start with a select star, execute that, and we see we have the order number, order date, and order customers. Do a sanity check. If today is September 26, 16, are we going to see any of these that are within a year? And yes, indeed we are, so that will be fine. And so let's go ahead and refine this and then add the clause we need to create that as a view. Okay, so what we need to add to this is we need the where statement, and what we would like to add in is where the order date, this, is greater than or equal to this date add function, the current date added to minus 1 year, so going back 1 year. Let's do a sanity check and run the query. Okay, so the query is working just fine. Now what we would like to do is we would like to turn this into a view. Okay, so let's create view, and the exercise says call that recent orders as that query, and we run that, and it says it's completed. And if that is true, if that has been properly created, then we should be able to select star from recent orders. And there it is. And we can treat that just as we would if it were an actual table. So we could add a, to our select star from, we could add a where customer num equal 334, and that should give us 1 result. And there it is. All right, so beautiful, first one down. Take a look at the second problem. The second problem parallels our exercise 2 on the HCIT database, and that says create a view that uses the recent admits view. We're using the recent orders view as its from source, and yes, you can build a view on a view. Name this view recent admit count. The query for the view will be an aggregate query, so we're either counting, summing, or averaging, right? That's what an aggregate is, grouped by patient ID, which provides the count of each patient ID. Label the counted column readmits. So we're looking for, this kind of tells me we're looking for people who've been admitted multiple times, right? At this point, the view lists the count of all admissions in the past, and this example was 5 years. Our example is 1 year. Add a clause to the filter that view the view so that only records for patients who have been admitted 2 or more times are displayed, which is to say where this count is greater than or equal to 2. Here's our parallel problem. Create a view that uses recent orders named recent order count. The query for this view will be an aggregate query grouped, how about grouped, by customer num, which provides the count of each time a customer num appears with an order. Name the field displaying this count as multiple orders per year. So in the last year, how many customers have purchased 2 or more times? It wasn't just a fluke. We're getting a customer loyalty thing, right? Our marketing department loves to know that kind of information. Add a clause to the filter to view so that only records for customers who place 2 or more orders in the last year are displayed. So very, very parallel. Let's go ahead and build that out. And again, we're going to start not with the create view, but with the select query. Okay, so we could say select star from recent orders. Oh, orders. There we go. So we've just done a select star on the view. So we're building a view on a view. Right now we're building a query on the view. And we need to change that to do some aggregation. So let's see. Let's, instead of selecting star, let's get the customer num. And let's get the count of customer num. And let's call that multiple orders per year. And better drop that into single quotes because I've got spaces in between it. From recent orders. And in order for that to work, I have to aggregate. I need to have a grouping. So let's say group by customer num. And let's just stop there and see if that much is working. It is. Okay, so customer 126, we got 2 orders in the same year. In 586, we got 2 orders in the same year. Everybody else is just a onesie order. Okay, so now we're ready to add our additional filter. And so having count of customer num greater than or equal to 2. Sanity check it. Yep, that looks right. And now that we've seen that that looks correct, we can go ahead and create the view. So create view recent order count as, and if we run this, it should just say that we created it. Yep, command completed successfully. And now we can sanity check our work by saying select star from recent order count. Highlight the query we want to run, and there it is. Great. Okay, so now we've got a view looking at a view, and sometimes that actually is pretty reasonable to do. That is a useful thing to do, but other times it's kind of wasteful. We can do it all in one shot. Let's go ahead and consolidate that down. So how can we consolidate that down? If we go back and look at the 2 that we created, one can become a subquery for the other. So here are the 2. And what we would like to do is consolidate these 2 together. So the inner query is going to be all of our date add stuff. So let's get rid of the create statements and wrap this in parentheses. And if we give this a name, we can take a query that we've wrapped in parentheses and give it a name just like we would give an alias to a table. So if we were pretending it was a table, we could say, well, that table's T. Okay, so give that a nickname T. And now what we'd like to do is go ahead and put that inside the other query. So we need to take our select customer num, count customer num as multiple orders per year, add a from, and I'll tell you what, let's just tab that in so it's kind of obvious that it's in set. All that as T. And then group by customer name, customer num, having count. Does that work? Let's give it a shot. Yeah, returns the exact same result, which is what we were hoping. And now if we're happy with that, we can create our consolidated view. Create view something as, and what did we want to name it? Let me see. The instructions say, call it multi-recent orders. Multi-recent orders. Give it a shot. Completed successfully. Sanity check it here. Select star from multi-recent orders. Highlight just the query we want to execute. There it is. And now we have that view established, and we can start using that to our benefit. Great. All right. So that's the first three. Let's take a look at number 4. So number 4 in our actual assignment, the HCIT database, create a view named Patient Lab Billing. And this is, you've got to think about it, but if you say it out loud yourself, sometimes it's easier to hear it, what you're doing, the word problem. This view will display each person's first name, last name, admission ID, total charge, and total Medicare charge. Okay, so what that tells me right away is if I'm going to have the patient's name, and I also got the total charges, I know that I'm going to have some table joins in the data model because I don't have the patient's name and their charges in the same place. The other thing that I got to figure out, if it's total charge, that suggests to me that I'm going to be doing some aggregation, because is that the total charge for this visit? Is it the total charge for this batch of labs? Is this the total charge historically? What have they paid, ever to date? So now I need to think about what I'm doing again. This view will display each person's first name, last name, admission ID. That gives me a clue that I'm consolidating the total by admissions, or at on a more granular level for each group of labs or something per admission. Let's read on. To provide total charge and medical charge field, you will need a subquery in the from clause, yes. You will also need an explicit join in the from clause to create an equijoin between lab codes and labs on lab code ID to provide the total charge and total Medicare charge. Wait for it, there it is. Calculated fields in subquery use an aggregate query on labs grouped by admission ID. So they're totaling by admission ID, which calculates the sum of lab charges as total charges and calculates the sum of lab Medicare charges as total Medicare charge. The outermost query must also perform some joins in its where clause. Person and admission must be linked on patient ID. The aggregate query, which you may alias as, for example, L, must be joined to admissions on admission ID. So we're taking that query and we're aliasing it like we do a table so that we can have a moniker to use for doing joins into the query. Okay, that it sounds really complex. It's not really that bad once we've seen it done. So let's take a look at seeing that done with the parallel exercise. So the parallel exercise says, create a view named order totals. This view will display the customer name, order num, and order total for every order placed by each customer. Okay, so if you think about it, in an e-commerce database, one order may have multiple items. On each line item, so each item goes on a separate line in your invoice, you could buy one of those hairbrushes, or you could buy 5 of those hairbrushes, and you could buy 3 of those toothbrushes, and you could buy 2 of those packages of Q-tips. Each one will be a line item. In order to get the total cost, I got to take and find the cost for each line, which is going to be the number I'm buying, how many packages of Q-tips am I buying, times the individual price. That gives me the price for the line item. Then I need to get a sum of that number in order to figure out what the total cost for the order was. And a customer may have or may not have multiple orders. Okay, so simplest case is one customer with one order when they bought one thing. More complex case is I've got a customer who bought, had many orders and bought many things, and many of each of those things. Okay, it doesn't matter. This query is going to handle them all. So to do this, you will need to compose a subquery to aggregate or sum the total charge for each line item on each order. The total line item charge is determined by multiplying the item price by the quantity. Okay, so how many packages of Q-tips by $1 a piece, whatever, of that item being purchased on a given order. This subquery will need to preserve the order number. Okay, so in that aggregate, in that group by, I need the order number there, right? Later, I'm gonna link that through my order line table to what customer ordered it. So I'm gonna need to link it back to the customer number in order to get the final form. So that's kind of why I've got to preserve that order number, have something to link on. Then the outer query can join on the order number field, linking in the orders table and customer table in order to provide a final display result, which is going to be, and here's what kind of summing it all up as if we could see it: customer name, order num, order total, excuse me. Okay, so here's the whole hairy solution, but let's see how we get there piece at a time. Okay, so it says we're going to work on this as first through a subquery. And so that subquery is going to be working on totaling those orders a lot like this. Okay. Okay, so we're going to select the order number and then the price times the num ordered as ord total, and we're going to take the sum of that from ord line and item, or ord line item, so here's the join, equals item num, and group by order num. Okay. So let's take a quick look to see how we got even that far along the line. Let's start with select star from order line so we see what that looks like. Okay, so the order line gives us the order number, the item number, the number ordered, and the quoted price. And we're also joining that to the item. And the item, I have the item number, the description, the on-hand quantity, the category, the storehouse it's in, and the price. A lot of this I'm not really interested in. I need the price, and I need to go back to order line in order to know how many that we ordered in that order. So I can say if I bought 5 at $22.99, then that's going to be 5 times $22.99 to get the total. Okay, so build that out and say select order num, and then price times num ordered from order line item, where order line dot item number is equal to item dot item number. So there's my join. Okay, let's see what this gives me. Got to identify item dot item number. It's ambiguous. Okay, so this gives me the result of the join, and I've got the total in there. Now, right now, this is not the order total. This is the line item total, if I wanted to be technical about it, and I do. So there's the line item total, but what I'd really like to do is I'd like to get the sum of this. Once I have the sum of all the line item totals, then I have the actual order total. But if I'm going to use an aggregate function here, I have to do my grouping. Oh, don't end the batch yet. Okay, so now I've got a consolidated of each item. Now remember, these are not each item, each order. But remember, one customer can have multiple orders, so I need to map those back to the customer as well. So all of this that I've just created is going to become a subquery. Okay. All right. And this is this subquery that really gives me what? The order total. What's an easy way to remember that? Let's say as OT, order total. Okay. Now, this is going to be, this whole thing is going to be like one table that becomes part of a bigger join. So let's make a little more room and see, what did we ultimately want? We wanted to get the customer name. Hi, Priyanka. Oh, I saw you for a moment. So I'd like to get the customer name, and we'd like to get the order number. But I have multiple tables that have that field, so I need to specify which one, so disambiguate it. Orders.order num. And I'd like to get from this thing that I'm calling OT, I'd like to get the order total. OT.order total from this, but also I've referenced fields from a couple of other tables in here. So the other tables, there are orders and customer. And as some of us found out rather in a hard way with the last exercises, anytime I'm going to reference the tables, don't leave your tables dangling. I have to join them. So how many objects here that we can interpret as tables do I have to join? The OT query is 1, orders is 1, and customer is 1. So I need to join 3 different tables. First line to join the first 2 is going to be where customer.customer num equals orders dot customer num, but don't stop there. We got another one to do. Orders dot order num equals OT dot order num. Okay, have we got it all? So we are 3 tables joined, 1, 2, 3. So you count the first one as 2, A to B and then B to C. So 2 plus adding 1 more in is 3. We should be completely joined up, and let's see what we get. All right, so this is what we're looking for. It would be nice if our customers were grouped together, so we could do this, order by customer name. Here's the problem though. We're going to create this as a view, and you can't specify ordering in a view, so we're going to have to drop that up. But see, if I do use that temporarily in a query, all my customers group right together, and I could see what the grand total of all their orders would be pretty quickly, right? And that may be where I'm going with that view. I can run reports off that to make grand totals really easily. But I can't put the order in the view, so let's drop the ordering back, and let's add this as a view. So create view something as the following. And what did we want to call it? I think it said we were to call that order totals. Give it a shot. Created successfully. And let's sanity check our work. Select star from order totals. Oh. Let's highlight only the query we want to execute. And there it is. And notice that it's not sorted, but once we have it in a query, we can order it by customer name very easily. And that gives us a nice consolidated report. All right, useful stuff. Very useful, and a lot of work to build it out the first time, but once you've got that view, you can see how handy that's going to continue to be on an ongoing basis. All right. For the final exercise, we need to pop over to use our 117 database in the, let's see, what do we call it here? Yeah, CIS117. That's what I named it. But before we get carried away with that, let's take a look at the actual problem that we're going to parallel. So in our HCIT database, what the assignment has you doing is create a view named long admits. So right away I have a hint there that we're looking for people who are hospitalized for very long durations of time. That's of an interest to us as healthcare providers. That's of an interest to us in terms of costs and insurance billings and all kinds of things. It impacts our revenues. So all kinds of things we may need to look at. Also, if you wanted to ever get paid back, maybe if you got long admits, you need to have your financial folks be a little proactive and go talk to the patients and make sure that they have a payment plan and all that kind of stuff. So increase your chances of recouping on what you're owed. So lots of reasons we're interested in long admits, both for the health of the patient and the fiscal well-being of the hospital. Okay, so this view is to list the patient ID, last name, first name, phone number, and number of days admitted. And that's going to be defined as the difference in days between the admission start date and the admission end date. So we're doing another one of those date add kind of things. Add a clause to filter the list to display only admissions lasting longer than 2 weeks. So that's going to be what we define as a minimum long admit is 14 days. And the hint is we're going to need to go back and use that date diff function again. All right, well, you should be able to make hay out of this, but let's go ahead and practice it anytime or anyway using the CIS117 database. And it says, use the CIS117 database, create a view named Slow Fulfillment, which will display the customer ID, first name, last name, phone number, order ID, order date, ship date, and the duration in days between the order date and the ship date. That's what we mean by slow fulfillment, is when it takes too long between the time the customer ordered it and the time we ship it out. And we probably offend some of our customers if we're too slow in getting them their product. They want it right now. And so maybe our marketing department is going to send them a little apology note and maybe a coupon for something off their next order. Or maybe we take a look at our shipping team, our fulfillment team, and say, hey, is there something wrong? Are we not getting product in? Are we not getting it off the shelves in time? Are we short-handed? You know, maybe we got a plan for holiday seasons and bubble support and bring some temporary workers in. All kinds of good things that the database can tell us if we take the time to mine it for that information. Okay, and so it considers a slow fulfillment anything that took more than, not more than or equal to, notice, more than 7 days. So 7+ days to ship. And it says exclude orders which have not yet shipped. And that sounds pretty challenging until I think about it and go, wait, if it hasn't shipped, it doesn't have a ship date. So the ship date is going to be null. Oh, I can use a where clause and get rid of anything that where something is null. No problem. That's a piece of cake. So that's not really as bad as it sounds. Okay. The bigger job is to do the join, because I know if I've got the customer first name and I've also got shipping dates, those are in separate tables. So I'm going to have to do some join work here. All right. So again, let's start with the simplest piece, getting the joins done. So given what I had there, I'm going to have a couple tables. Customers and orders. So let's start with our old friend, select star from customers, orders. And how do we join customers and orders? Where customer dot, is it customers instead of customer? It is. Dot customer ID equals orders dot customer ID. And so that's what the whole crazy join looks like there. So there's the whole thing joined together. And do I have ship dates? Yes. Do I have order dates? Yes. Okay. So let's trim down a little bit and say, what do I need? I need the customer ID. I need the first name. I need the last name. I need the customer phone number. And I need the order ID. And I need the order date. And I need the shipped date. And then I'm going to need some calculation of the dates between them, right? So we'll add that in a minute. And I notice that I have IntelliSense complaining about customer ID, first name, and last name. Customer ID, I know, is going to be ambiguous. I got to say, where do I want to get that? How about we get that one from customers? And then first name and last name, those should be, oh, customer first name and customer last name. I just need the whole field name in there. Okay, can I do that? Yes, I can do that. Okay, we're banging it into shape little by little. So now I need another field out here that's going to be the difference between those two dates. So this is going to be another field. I'll just put a comma in here and put it down on the next line. And I need to have the date diff function again. Date diff of two dates. And first thing I need to say, date diff, is what's the unit? Before it was year, but it's not year that we want this time. It's actually in the number of days is going to be the unit. And it's going to be between the date it was ordered and the date it was shipped. Okay, let's see if that's working. No column name, but I am getting the date differences. Sanity check, 10/23 and 10/28. Yeah, difference would be 5 days. I'm believing it. Okay, but I was told to give that a specific name. So let's say as, and what do we call it? Delay, right? Execute it again. Great. So for Cora Blanca at this phone number, order ID, it was 5 days. But wait, we don't want 5 days. We only want it if it's more than 7 days. So let's add something more to our where clause, right? And so we could go copy this expression, because we're going to use it, and say, and something is greater than something else. So it's going to be where this expression is more than. Is it more than or equal to? No, it was more than, not more than or equal to, more than 7. Sanity check, am I seeing results that it's only 7 days or more? Yep, I am. So that's looking good. Okay, and what else? Now I notice in this case, there are no dates for which something was not shipped. But that's probably just luck of our data. Okay, what if we were to go into the table and add an order that was not shipped, or go and take something out that was shipped? So let's go and do that. Let's go grab, let's see, one of those orders, order ID 70. And let's go over to our orders table. Yeah, oh, this isn't on TAL. This is on 117. And yeah, let's take this and edit the top 200 rows. And let's go find, do we know what the order ID was that we were looking for? Order ID 70 is one. Let's pick another one. Actually, I think we probably, oh, there it is, order ID 70. I was looking right at it and missing it. So let's go in here and just whack the ship date. Okay, so the ship date there is now null. And so now if we rerun this query, oh, I think I know why we're not seeing it. Let's kill it. Ah, yeah, so there's our null showing up. And so, wow, does that take care of it automatically when, oh, that's cool. So that gets rid of the nulls. If we wanted to filter that out beforehand, looks like it's kind of redundant because our logic's going to remove it anyway. But let's just, for the sake of argument, say, how would we do that? We could say, and shipped date is not null. And now we get rid of it. So this is kind of redundant, but that gets rid of it. And have we met our requirements? We have the query, we haven't created the view. We're going to create this view as slow fulfillment, and I think in other respects it meets the requirements. So let's say create view slow fulfillment as, and run it. Oh, I already have one. I forgot to drop that. So let's come over to the views on the database. There it is. Let me delete it. It's gone. So now if we create it, there it is. And sanity check our work, select star from slow fulfillment, and highlight just the query we want. And there it is. So again, very useful query. Questions, anyone?
I think I'm okay. I think I just need to practice a little bit.
The biggest challenge with these is trying to turn them from word problems, from the written specification, into what we're actually looking for. And that's why I think seeing a visual example of a comparable problem is really useful for these, because the word descriptions get a little bit convoluted. And what will save you is always start with select star, then build the inner query, and then gradually grow out and whittle it to pieces, bite-sized pieces, one at a time, rather than taking on the whole project in the same query. When you want to try and sit down and write the whole masterpiece, doesn't work that way.
Okay.
But maybe it does for you. I mean, there are people that are a lot brighter than I am, but never worked for me. So
definitely not. It's just like with programming. I have to constantly print to the console or log just to make sure I'm actually getting what I'm expecting to get. And if not, I need to figure out why. It's same concept here.
Yeah, it's incrementalism. And I had a wonderful mentor in my grad program, a fellow by the name of Dr. Muhammad Ayati. And Dr. Ayati used to say, Beck, complexity is merely the aggregation of simplicity. And what he was reminding me is that you don't solve big problems. You subdivide big problems until they are small enough. You repeatedly subdivide them until they are small enough to be tractable. Then you solve small problems, because that's what mere mortals are capable of. And he was also reminding me of that I wasn't quite as big as I thought my britches were. Maybe there were people who did have superpowers, but I had to wrestle with my delusions of adequacy. All right. Well, that's what I've got this evening. I'm happy to entertain questions or anything about the past week's work or the coming week's work that's come up.
Hey John, I have a question of assignment 5.
On assignment 5, okay.
Yeah. So I was confused how if there is an error of violation of primary key, how to just get the results. I did it twice, I executed it twice, and it was causing error.
Okay, a primary key violation, it usually has to do with trying to insert data on and the key already exists. Okay, so let's see an example of that and see how we would deal with that. So let's go start a new query, and I'm going to go ahead and use CIS117DB. And let's see what would be a good table for that. Any of them would be fine, but let's do customers. And here's what I'm going to do. I'm going to cheat, and I'm going to go grab DBO customers, and I'm going to say script table as insert. Okay, and I'm going to send it to a new query editor window. And now it's all set to send a new value into that. I'm just going to type in what I would like those to be. And I'm going to cheat even further in that I'm going to open up another query window. And let's say, give me the top 1,000 rows. So I see that customer ID key, and this is the primary key, customer ID 1 is already taken. Okay. So if I go back to where I've scripted this, and I'm going to come in here, and I'm going to put here 1, and then the first name is going to be John, and the last name is going to be Beck, and the address is 123 Happy Avenue, and the city is Santa Barbara, and the state is going to be CA. 93113, and the phone is going to be 123-456-7890, and the fax will leave null. And if I execute that, let's fix the syntax problem first. Extra comma. All right. So this is what you're getting, is a violation of primary key constraint. And it exists because 1 already exists. So what if I were to change the key value? Does it work? That works. If I run that again, it fails because it's just been added. But if I were to change it slightly to one that doesn't exist, it works. So here's what happens when you're a student studying, the inserts. You do some inserts and they work, and then you forget to do the deletes, and then you come back and the inserts don't work anymore because you've already inserted them. So the easiest way to deal with that, Priyanka, is to just wipe out the database and rebuild it. So in the case of the 117 database, I've given you a script that rebuilds the whole thing. I don't even have to delete it first. I can just go ahead and open the file. And so let me go File, Open, File, and let's see, where did I leave it? Create CIS117DB SQL. There it is. Execute it. Oh, you know what? I was using it. I still have it. I still have it open. What I ought to do is, let's do this. Let me disconnect. That way I can leave the queries in those and connect. And so those shouldn't be live until I run them again. But this one I should be able to run. All right, let me kill it manually. So I use master, so I should no longer be using. I may actually have to drop those query windows. I don't think they maintain a cursor, but let's see if I can just delete this database. Should drop faster than that. I may actually have to drop those other queries. It may keep a cursor open from those other query windows. Yeah, drop failed. Okay, so I'll tell you what. I'm gonna come over here and I'm gonna copy that and cache it over in my notepad right quick, and then we'll drop this. Yes, no. We'll drop this. And we'll drop this. Okay. And use master. And now let's see if it'll allow me to delete it. Yeah. Okay. So now if you look, that database is gone. If I just rerun the create script, bam, it's created it. So now if I refresh, we see that it's back. And now if I create a new query, only I'm going to go grab that from Notepad. Okay, so a moment ago when I did this, that didn't work because the primary key was already in use. Now if I run it, it works fine. If I try and run it again, I get a primary key violation. The other thing that I can do on this one, can't do this on HCIT on all the tables because some of the tables are pretty good size. I made a lot of sample data for them, but I could come over here to the customer table and edit the top 200 rows. If I scroll down to the bottom, I think we will find, here it is. And so I could also just do this, kill the record. And now I can pop back over and run that query again. And it's happy. The trick is I gotta delete those keys that I've added if I've done inserts because I can't run them again without dropping them first.
Yeah. So we need to drop that table and then.
In this case, in the case of a student database, that's the easiest thing to do. If this was production data, you wouldn't just willy-nilly go delete data. We would go back it up, or we would go and edit it or alter it, that kind of thing. But if it's just sample data or test data, and you have a script that recreates, that's why I gave you guys a script that rebuilds it. The easiest thing to do is just come over and you can kill all your current connections, and if you have the current connections all killed, then it should be really easy to come over and you shouldn't even have to do this manually, but you can delete the database. It should, I may have to drop the connection altogether. Yeah, it shouldn't take that long. It's going to fail.
Yeah, because I tried, like the ones I was working on, I tried to remove that.
Yeah, what you need to do is see it remembers it's still holding a connection in which I have let me see, control break should kill it. Where's my break key? No. Okay, but it's holding a connection. So what I can do is you can either drop the connection and then reconnect, should reset it. Or the other thing you should do is you bring up a query window and you say use master, and that's the only query window that's open, then you're no longer using that current database. And so now if I go over and delete it, it should drop like that. So let's give it a try. No, it's still got a connection to it. I don't know why the connection persists.
I think it's better to take like reconnect it and do.
Yeah, I've noticed that the way that SQL Server Management Studio works is a little bit funky at times. So let's try it. If we drop the connection, redo the connection, and now if we come in and delete the database, yeah, it's just that quick. Okay, so now we can go ahead and file, open, file. There's the create script, run it, bam, it's done, and we're back in business with a whole new clean data set, pristine and ready to go.
Yeah, that's better.
Yeah. So there it is. Other questions? Great question, by the way. That's very useful.
Thank you. Thank you. I think I was just struggling with that right now. Yeah.
Yeah, it can be particularly frustrating if you're dealing with a remote database where things work a little bit slower, and sometimes if you're using like an Amazon instance, if it's the AMI, if it's an Amazon machine with everything running on one machine, it may be useful to stop and restart the instance. Don't terminate the instance. Don't delete it, but just stop the instance, restart it, and that may clean things up. And if you're using an RDP database, you may need to make sure that you've completely closed your SQL Server window and restart it before you get a clean connection. And sometimes if it's going through a proxy or an intermediary of any kind, it can take a couple more minutes before the connection really has terminated on the database side and allows you to drop the database. I've seen a little latency from time to time. Most of the time it's pretty snappy though.
Thank you, John.
You bet. All right. Well, if nobody has anything else, I'm going to end the recording, and thank you so much. And of course, if things come up during the week, this is not your only chance. You're welcome to call me or email me or post to the Q&A, and I'm happy to do screenshots or even a little, mini movie to address a parallel problem or to help solve a particular issue if you're running into things that just don't seem to be working.
Thank you.
All right. Have a great evening, everybody.
You too.